This is grade 5, module 1, lesson 14, and the objective in this lesson is to divide decimals with the remainder using place value understanding and relate to a written method. So we're going to start out with problem number 1 from the homework, and it's to use the place value discs or the number disc in the place value chart to solve and show each step using the standard algorithm. Okay, so to set this problem up, we're going to have to put in our discs or our dots, and I'm looking at this number right here. So I have 5 in the ones place, 1, 2, 3, 4, 5, 2 tenths, 4 hundredths, 3, 4, and then 1 thousandths. And I'm dividing it by 3, and you can kind of see they have them marked out here, these 3 rows. Okay, I'm going to erase that so it doesn't get confusing. So now I'm going to be bringing the dots down into those different rows. So I'm going to bring my 1 dot here, and 2 dots, 3 dots. That gets rid of these 3. Okay, and I have 2 left over. So what happens is I'm going to unbundle these. I don't have enough to make those divide those out evenly. So I unbundle them. So 1 ones becomes 10 tenths. So 2 ones become 20 tenths. I'm going to just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So now I have 22 dots, and I can put them in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so that takes care of 21 of my dots, and I have 1 left over. Oops. And my 1 dot is going to go over here and be unbundled into 5 hundredths. And again, I have 10, 11, 12, 13, 14, so I'm going to put them down here. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 4. I don't have enough, so I use 12. I have 2 left over, and I bring them to the thousandths place. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that uses up all of these. Okay. So I just need to look at one of my rows, and my answer is going to be there. So let's just take a look at this row right here. I'll write the answers right underneath. I have 1 in my ones place. I have 1, 2, 3, 4, 5, 6, 7 in my tenths place, 4 in my hundredths place, and 2, 4, 6, 7 in my thousandths place. Okay, so now I'm going to be using the standard algorithm and see how this compares. So my first part, I had my 3 here, and I have to see how many groups I can make out of 5, which is what I did over here. I had my 5 ones, and I had to split that up into my 3 groups. So my answer was 1. I was able to fit 1 dot in there. So I can put my 1 right up here. Okay. And then I'm going to go ahead, and I had 2 remaining. So my 2 that I have here is these 2 that I have left right here. I unbundled those, and I added it to the tenths place, and that's the same as taking my 2 here and bringing it down to get 22. So now I have 22 tenths. And so that was my 22 tenths here. It's the same as 22. So I had to divide that by 3, and my answer was 7. I had 7 in each one of these, so it's still 7. Okay, I'm kind of going ahead here. So I had my 21, and I had 1 left over that I brought over, and I unbundled. So I have 14 hundredths here. That's what the 14 is. And then I have 14 divided by 3, and that answer is 4. 2, 1, 2, 1, and this one is 7. So I did get the same answer. I'm going to show you a little modification that I did with my students, and it just was easier just because we have sometimes the spaces that they give you are not as big as you need them to do all the dots. So what we were showing the students is just how to do this using just the digits. Our students are very familiar knowing that if I draw a 5 here, this is the number 5. They know that this represents 5 of something. So I have 5 ones, 2 tenths, 4 hundredths, and 1 thousandths. So I'm going to put a 1 in each one of these. 1, 2, 3. That means I have 2 left over, and I'm going to just bring that right over here. Okay. So some of my students who aren't very good with their facts can write their multiples of 3 on the side, but most of the students know their basic facts. So they'll know that 3 times 7 is closest to 22 without going over, and it's actually 21. So if I have 22, I used up 21, I have 1 left over. And then I know that this is 4. And they know that there's 2 left over here because 3 times 4 is actually 12. So there's 2 left over here, and I'm bringing them to the tenths, to the thousandths place over here. So I have 21 thousandths. And they know that if I'm dividing by 3, 3 times 7 is 21. So there's no remainder for this, and they could just circle their answer or use their answer right here. It's a nice little strategy they have there. Okay. The students are not as familiar with the standard algorithm, and even if they know how to do it, they have a very hard time explaining what they're doing for each one of the steps. When they're doing on the place value charts, they can tell you what each of those place values are and divide them by 3.